Welcome to REDSHORT 2021. This Wednesday, we are showing an ENCORE presentation from our REDSHORT Threat Brief Archive. In the intel world, an analyst is expected to be brief, be right, and be gone. We hope our REDSHORT briefs are just that, of interest and useful.
Good morning, everyone, and welcome to our REDSHORT webinar today. Today's webinar, we will be comparing the Conti and the Ryuk ransomware. A link to a related article will be made available in the chat box as well. The past few months have seen a new ransomware variant emerge that is being distributed by the TrickBot malware. The appearance of this new ransomware named Conti has corresponded with an observed decrease in Ryuk deployments. And this suggests that Conti is the successor, quote unquote, of Ryuk. Some media outlets were also reporting that Conti was an evolved version of Ryuk, which means it originated from the same source code base. And while this may have been true for very, very early samples, a Red Sky analysis of recent Conti and Ryuk samples tells a different story. As we will show, they both share capabilities that are common with other ransomware, but there are significant differences in implementation and at the machine code level. Ryuk was initially identified in August 2018 by Checkpoint Research, and it was attributed to the Russian cybercrime group Wizard Spider as a descendant of the Hermes ransomware. Wizard Spider operates the TrickBot malware infrastructure, and it is thought that Wizard Spider took a leaked copy of Hermes, which was thought to be developed by North Korean malware developers, and modified to become Ryuk. Ryuk was initially observed being manually delivered via the TrickBot infrastructure by Wizard Spider, who usually targets large organizations with the goal of ransoming victim data for large amounts of Bitcoin. Now, the first ransom notes observed were asking for payments between 15 and 50 Bitcoin. And in January of 2019, a CrowdStrike analysis of the Bitcoin addresses associated with Ryuk showed a value of over 705 Bitcoin in those accounts, which at that time was equivalent to approximately $3.7 million US. In February of 2020, the FBI estimated that Wizard Spider had netted over $61 million US from Ryuk over its lifetime. A suspected development build of Conti was discovered on VirusTotal by Twitter user rbaby_mr in February of 2020. And the first discovery in the wild was reported in July of this year. Soon after that, in September, Conti hit the U.S. 4th District Court of Louisiana for an undisclosed ransom amount. Conti is also attributed to Wizard Spider due to its distribution via the TrickBot infrastructure. Although ransom amounts at the time of this report have not been disclosed in the media, we expect ransom amounts to be similar to Ryuk since they are both operated by the same group. Some of the similarities between Ryuk and Conti are at the high level in their capabilities, but they differ greatly in their implementation details, significantly enough for us to conclude that they are not related at the source code level. They're both deployed manually and can be delivered via the TrickBot infrastructure. However, other payloads have also been observed delivered by TrickBot in the wild, such as crypto mining payloads. And this feature alone is not enough to conclude that Conti and Ryuk evolved, or excuse me, this is not enough evidence to conclude that Conti evolved from Ryuk. They both also are able to encrypt multiple files at the same time to reduce the amount of time it takes to encrypt a victim's data store. For network defenders, this means that the window of time they have to detect and stop these two ransomwares before all of their data is encrypted is drastically reduced compared to other ransomware. What once took hours can now be done in minutes. However, the way in which each ransomware goes about performing these parallel file encryptions varies greatly, as we'll soon see. Both ransomwares use a combination of AES and RSA encryption to encrypt a victim's data, with slight differences in the algorithms that are used and the way that keys are stored. Lastly, they both contain a list of operating system services and backup software to disable before executing the encryptor payload to prevent the victim from restoring data without paying the ransom. This is perhaps the most similar feature between the two ransomwares, but this is also a very common technique among other ransomwares as well. Now we'll discuss some of the differences between the two ransomwares. First off, we'll talk about SS-deep analysis. SS-deep is an operation known as fuzzy hashing, and what that does is it compares files and scores them as to how similar they are using a percentage. A red sky analysis of 65 of the most recent Ryuk samples and 6 of the most recent Conti samples available from VirusTotal showed 0 similarity using the SS-deep score. This is a significant static analysis finding because at least some similarity would be expected if the two shared a common code base. Secondly, red sky analysts performed reverse engineering of these Ryuk and Conti samples to determine if there were any implementation details in the way each ransomware operated that was similar. And what we found was that there were more differences than similarities. In fact, the only similarities found were at the high level that we discussed in the previous slide. For the fast parallel file encryption feature, Ryuk will actually create multiple copies of its encryptor payload on disk and then run them from disk to encrypt multiple files at once using the Windows API function shell execute. This creates entirely new processes at the operating system level. In contrast, Conti uses the lighter weight operating system threads feature to run 32 copies of its encryptor directly from memory without writing anything to disk. This is an extremely significant difference in the implementation of that same feature using different methods. The encryptor payloads also use slightly different RSA algorithms and store their encryption keys in different formats. This causes even more differences in code in the part of the ransomwares involved with configuring the Windows cryptographic subsystem. This is less significant because the labor involved to make this change would be significantly less than that fast file encryption feature we talked about, but it is a difference nonetheless. Let's see, Ryuk has no runtime infection markers. If it did, it would not be able to run multiple copies of its encryptor payload to perform that fast parallel file encryption that we discussed on the previous slide. The absence of this feature from Ryuk is a significant difference between the two ransomwares. Conti, in contrast, creates a named mutex named __ Conti __. And if this mutex is present when the ransomware is initially triggered, Conti will terminate without running the encryptor payload. In fact, red sky analysts were able to prevent a test victim virtual machine from being encrypted at all by any of the Conti samples that we analyzed by writing a program that created and held an identical mutex open. It acted as a kill switch in that way. And the presence of this kill switch is a traditional malware feature to prevent multiple copies of a malware from running at the same time. Ryuk depends on multiple copies of the malware running at the same time to get that fast infection. DLL imports were another area of difference found between the two. Ryuk uses the traditional method of relying on the PE executable's import address table, which is the technique used by most legitimate software. Conti, however, obfuscates the DLL imports that it uses by manually importing them at runtime using the Windows API's load library and get proc address. This is another significant difference in implementation. It is also worth noting that Conti can be configured by the operator at runtime using command line options when launching the ransomware. And using different command line options, Conti can be configured to encrypt only local drives, only accessible network shares, both local drives and accessible network shares, or only network shares being shared from a specific IP address. Ryuk does not have this kind of configuration at all. And lastly, while a difference in the ransom notes is less significant because the ease of which they can be changed from campaign to campaign, it's worth noting because Conti was originally reported to use the Ryuk ransom note template. However, it's essentially just a text file and easily swapped out for a new one by the operators, and it really has no effect on how the ransomware operates. But here we have two recent examples of ransom notes from Ryuk and Conti. In conclusion, little evidence was found for the assertion that Conti and Ryuk evolved from a common code base based on analysis of SSD hashing, ransomware capabilities, and implementation details. I'd like to thank you all for joining us today, and if you have any questions regarding the topic briefed, please get in touch with Jay McKee at wapaklabs.com. If you missed any of our previous REDSHORT reports or webinars, you can find them at redskyalliance.org/REDSHORTs. If you're not a member, you will need to sign up, but your membership is free and it will give you access to all types of Red Sky Alliance content. Have a great week, everyone.